we've got a problem here where we're talking about the population at a bird sanctuary. It's varying on a yearly basis. We've got a low, we've got a high, and what we want to do is come up with a trigonometric expression that will model that bird population as a function of the number of months since the start of the year. Now when I'm doing something like this, what I typically want to do is I want to start off with a graph. So let me go ahead and create a nice graph here. I am interested in values here on the t-axis for time of 0, 3, that's the 3 months there, and then I'll go 6, 9, for that 9 right there, all the way out to 12, which should be one period of the graph. Things are changing on a yearly basis. And then what I want on the vertical axis, let's call that P for population, is I want to make sure I'm marking the low and the high. So 2,000 and 16,000. Now, in particular, I know that I am working with a graph where I've got the low here and the high here. But there are a couple other things I want to fill in. It would be really good to kind of fill in the middle here, what we call the midline. And that's going to be halfway between 16,000 and 2,000. That's going to be 9,000. And the pattern we're going to see is we're going to see, all right, we're going to have midline, valley, midline, peak, midline. That's what our graph looks like. A couple of other things to note here. We're always interested in amplitude, which is the distance from a peak or a valley to the midline. So you can see that that distance right there is 7,000. Now with all this information, we can start to put together the parameters that we need to describe this trigonometric graph. So a couple of things here. We already know our amplitude. Our amplitude A is going to be 7,000. We know our period is equal to 2 pi divided by b, which in this case means that we have 12. That's the period, 1 full year or 12 months, equals 2 pi divided by b. And if you do some cross multiplying or however you want to solve that, that's b equals pi over 6. Now, we've got an a, we've got a b. We need to make a couple of decisions here about our trig function. So we need to think about what this resembles. Is this more like a sine or a cosine? Now I'll tell you right now, you can use either and you can make it work with appropriate shifts. But in a situation like this, I notice that we're starting at the midline. That's typical of a sine graph. Now a sine graph actually is going to go up. So a sine would look more like that. I don't have that. What I have instead is something that is flipped over. So I'm going to use a minus sign. So my model here is going to be the following. I'm going to go with a negative. Here's the amplitude, 7,000. I'm going to go with the sine. Now I need the b times the t. So that's pi over 6 times t. The one thing I haven't done yet is right now this is a graph that oscillates around 0. Its midline will be 0. And we need to shift it up so it goes up to a height of 9,000. So our final piece of the puzzle is going to be adding on a 9,000 here. So let's just review where everything comes from. We started with our graph. The distance between a peak and the midline, or a valley and the midline, gave us our A. That's the amplitude. One full oscillation was 12 months, so 12 equals 2 pi over b, b equals pi over 6. I look at this and I go, it looks like a negative sine graph, so that's why I've got the minus and the sine, but I have to shift it up 9,000, and that's where the 9,000 comes from. And you can now check if you actually plot this on a graphing calculator or on Maple, you should get a graph that looks like that.